Good day, everyone, and a warm welcome to today's Tech Talk of Configit. I'm Jörn Ploys. I'm part of the global marketing team of Configit, and I will be your facilitator for today's Tech Talk. So our topic of today is stop configuration errors before they reach your customers. Configuration errors often happen right in the middle of a customer's buying journey and can be a big pain, as a lot of us know. And it can lead to a big frustration at the customer. So today we're looking at solution approaches to this. To introduce the topic, I would like to introduce our presenter of today. A warm welcome to Jesper Blak Møller. Jesper, he is a co-founder of Configit and has actually spent most of his professional career at Configit for, I think, more than 20 years now. During this time, Jesper has held different positions in consulting and delivery management. Today, Jesper works as Director of System Architecture of Configit, covering all of Configit's products. Jesper has profound experience in SAP integration, SAP variant configuration, and pricing from multiple custom projects and research from his past. On a note of his scientific career, Jesper holds a master's degree in software engineering and a PhD in computer science from the IT University of Copenhagen. Our Tech Talk today should take about 30 minutes, and then in the interest of time, I'd like to ask all valued attendees to please ask your question in the control panel on your right-hand side, where we will collect them and address them at the end in a short Q&A. But before we get there, I'd like to hand over to Jesper for his presentation. Over to you, Jesper.
Thank you, Jan. So if you work with product configuration, you know how difficult it is to avoid errors in your configuration rules. And product configuration errors always appear at the worst possible time, right when the customer is ordering a product. Or even worse, after the customer has ordered the product and you discover that you can't deliver it. In this Tech Talk, I'll show you how you can avoid this problem and stop configuration errors before they reach your customers. So in this presentation, you'll learn how to avoid costly product configuration errors by understanding why they happen and why traditional tools often can't catch them. I'll explain a new approach to validation of configuration rules based on a technology called virtual tabulation. And finally, I'll demonstrate how you can use interactive solution spaces to browse and explore product configurations in a graphical and very intuitive way. So overall, the goal of this presentation is to show you how you can improve quality, save time and money, reduce risk, and deliver better products faster. So let's get started. But before we start, I want you to think of the simplest product you can. Take 5 seconds, think of the simplest product you can. I asked one of my colleagues the same question, and he was thinking of a paperclip. It looks simple at first, but when you start thinking about it, it's actually a lot more complex than you would think. You have different types of material, you have different surfaces and colors, you have different types of wire, you have different edges on the wire, you have different shapes of the clip. They might be magnetic, they might have RFID tags. You probably want to consider how you can recycle this product. How are you going to package the paper clips? What about labels and boxes, and so on? The list just goes on. And we haven't even talked about how you want to sell and price the product. So as you can see, even very simple products are often much more complex than you would think. And especially because there are dependencies between all these options. You can't just choose freely. So how do you handle that complexity? Well, the answer is you use a configurator. So let's quickly recap how you build a configurator. So imagine we work for the company Snowmobile Motors, who wants to sell custom snowmobiles for their customers. And we have created a very simple product model with just 3 variables and 2 rules that define the legal product variants of the snowmobile. We can see we have 3 variables here that define the color, the engine, and the market. And we have 2 rules that link these 3 variables together. And customers can now configure the snowmobile in a very simple configurator. And they could, for example, choose a color, they could choose an engine, and the configurator will give response and make sure you don't choose an incorrect market. For example, here the US or Canadian market, given the choices that I've made. Very simple configurator. But how do we ensure that the rules that we have defined in this product model are correct? For example, how do we ensure that all the colors are available, or all the engines, or all the markets are available, or that all possible combinations of, for example, color and engine are available in some market, and so forth? We could test some of the combinations in the configurator, but the challenge is that testing only shows the presence of errors, not their absence. We could try this very simple algorithm. It's an exhaustive algorithm. We'll find all legal configurations, and then we'll check that each configuration satisfies the properties that we're interested in checking. So let's try this approach. Very simple algorithm to get an idea about how to solve this problem. We'll start with all the possible configurations of the snowmobile. So we have 125 of these different configurations. Then for each configuration, we'll check whether it's legal, simply by checking if the values in every single row satisfy all of the rules. And if they do, we paint the row green. So we end up with 65 legal configurations for the snowmobile. And now it's actually quite straightforward to check the properties we're interested in. It's easy to see here that each of the different colors, the 5 colors that we've defined, are actually present in the first column there. And similarly for the engine and market. We can also convince ourselves that, for example, all possible combinations of color and engine are available in this table here. Or that if you select the US market, then only certain engines are available. But what happens when the model grows? What if we have 27 variables, each with 5 different values? How many configurations would we need to check? It turns out that there are 7.5 quintillion different combinations. That's 7.5 billion different combinations, or the same as the total number of sand grains, or insects for that matter, on Earth. So it's a huge number. It's almost 1 billion configurations per human being. And it would take decades for us to check all these combinations on the world's most powerful server. And even if we had all the computers in the world, all cell phones, servers, all laptops, all smartwatches, all embedded devices, it would still take hours to go through all these different combinations. And this problem is known as the combinatorial explosion. So clearly this very simple algorithm, even though it looks clever on the surface, it's not usable in practice. And it gets even more complicated because often products are modeled in different systems. Engineers use PLM to create a technical view of the product. Manufacturing use ERP to define which parts are needed to assemble the product. Sales use CPQ to describe which features are available in the different markets and how they relate to the usage of the product. And the service team wants to describe how you can upgrade and replace parts in the product when serviced. So when you have all these different definitions, multiple definitions of the same model in different systems, there is a high risk of misalignments and errors. And what happens if you don't get this right? Well, you risk that customers order configurations that you cannot deliver. You actually also risk that customers can't order configurations that you could deliver. And the consequence is, of course, that you effectively lose money, you waste a lot of time, and you destroy a good customer relation. So let's try to summarize this verification problem as follows. How do we verify that a single product configuration model is correct? For example, that all values are available, that certain combinations of specific values are available, or that some configurations contain a specific value for another variable. How do you check that for a single model? And how do you verify that if you have two versions of the same product model, that they are aligned and not contradicting each other? For example, that if you introduce a new feature or you change some rules in a model, that these changes don't cause errors, or that the two models are 100% aligned. So how do you check this without being blown away by a combinatorial explosion? The answer is you use smarter data structures and efficient algorithms. So Configit has invented a new technology called virtual tabulation, and that's designed to build and validate configurators. The technology is based on a graph-based data structure called binary decision diagrams, or BDDs. And when we compile a product model, we first construct small BDDs for each of the rules, and each BDD then represents the solution space of each rule. And here you see some simple examples. And because BDDs are a canonical representation of logical rules, conjoining two BDDs is a polynomial time operation. Canonical here means that if two rules define the same solutions, they are logically equivalent and therefore have the same BDD representation.
Yeah.
We then combine all the BDDs for all the rules into a larger graph that represents the full solution space of the model. BDDs are similar to the graphs that we are all used to in navigation systems, and that allow us to quickly navigate from A to B using the fastest route. And similarly, BDDs deliver unmatched performance for verification of configuration models. And in fact, BDDs are one of the only really true fundamental data structures that came out the last 25 years, according to Stanford professor and Turing Award winner Donald Knuth. Here's an example of a BDD for a product model of a snowmobile with 27 variables, 45 rules, and over 290 trillion legal configurations. And once we've compiled this BDD, we can use it to prove properties about the product model. For example, if you want to prove that all of these 290 trillion configurations satisfy the property if A, then B or C, for example, if the market is US, then the engine is either 800 or 850. We first build the BDD for that property, which looks something like this. And then we construct the BDD for the rule not R or P, where R is the full solution space of the product model. And because BDDs are canonical, once we have merged these two graphs together, we only need to check that the graph consists of just one node, the terminal node 1. And if that's the case, we have formally proved that all of the 290 trillion configurations satisfy the property that we're interested in. And this can be done extremely efficiently using BDDs, and it only takes a few seconds on a normal PC. I'll now show a demo of how this works in our product, Configit Ace. We're going to look at two different models of the snowmobile. The first model is an engineering model of the snowmobile that we've created in PLC Windchill. And the second model is a manufacturing model of the same snowmobile that we've created in SAP ABC. And I've imported these two models into Ace using our PLC extractor and SAP extractor. And I've compiled the rules in each model into a virtual table. And we can now use the verify module in Ace to validate the correctness of the two models. So let's see how that works. So first, I'm going to analyze whether the engineering model from PLC Windchill has any blocked values. So that's values that you can never select. And this can be very difficult to analyze manually because often it's not a single rule that causes such a conflict, but multiple rules together. So let's see how it works. So first I'm selecting the model I'd like to analyze. I'm looking here at the SAP model. And then I'm essentially analyzing what happens when the model has variables or rules that together have the combined effect that one of the values can never be selected. So as you can see, I get a detailed explanation of all the rules and how they together have the combined effect that in this case, one of the values can never be selected. And because I have a reference back to the rules in the original system, I can now go back to either SAP or PDC and fix the incorrect rule. And this will save me a lot of manual work. Next, I'll show you how you can look at your configuration rules in a completely new way. We call it the Solution Space Explorer. And it allows you to explore all the valid configurations in an interactive and very intuitive way. You can see the effect of all the rules in one view and how the rules restrict the different combinations of values. And this can be very useful if, for example, you're introducing some new variables or changing some rules in a model. So let me take a look at how this looks for the P2C model. So I'm selecting some variables here in the view, the ones that I changed in my rule. In this case, I'll start with the engine and the starting type. And as you can see, the tool here now gives me a visual representation of the solution space. It shows me all the combinations that are possible. And in this case, this is actually what I expected. All 10 configurations are possible. I'll then add the chassis to the analysis as well. And here I can discover that for one of the chassis, the ProRide chassis, one of the engines, the 600 engine, is only possible with a manual starter. And in fact, also the 850 engine is only possible with an electric starter. And this was actually not what I expected. And I can now include a few more variables in the analysis just to make sure that this error here is contained within those 3 variables and not sort of spreads further out in the solution space. So I can add a few more variables to the analysis and take a look at the solution space. I can, of course, use this information again to go back to my source system and fix the problem that caused this error here. As we'll see here in the next view, we have different types of visualizations that can be used to help you get new insight and better understand what is being offered and how the rules together restrict the solution space. For example, we have this heat map here that can be used to identify features that are rarely offered and which could potentially be removed to simplify the model. So the Solution Space Explorer allows you to visually explore the different solutions in your model and use that to validate your product models. The final demo shows how you can compare the solution spaces of 2 models. I'll compare the engineering model from P2C Windchill with the manufacturing model from SAP ABC. And the comparison takes all the rules into account in each model, and it allows me to see any differences or misalignments between the 2 models. So first, I've selected the P2C model and the ABC model as the 2 models I want to compare. And I select the variables that I've changed in the rules that I have modified, and therefore I would like to analyze. And I can see that the ABC model from SAP actually does not contain all the configuration offered by the P2C model. There are 7 configurations there that have been removed compared to the SAP model. And that might be okay. But I can also see that the ABC model allows 7 combinations of engine, starting type, chassis, and windshield that my engineering model does not allow. And this is clearly an error in the ABC model, because here I'm actually offering something in the manufacturing model that I haven't engineered. So I can now go back to my SAP system. I can fix the rules that causes these combinations to be allowed, talking about these 4 different variables here. So this way, this tool here gives me a very valuable insight into my models, and it allows me to align my PLM version of my model with my ERP version of my model, even across different versions of the same product model. Mm-hmm. So once we have verified the correctness of the models and ensured that they are aligned, we can then expose the resulting configuration models from either P2C or SAP through Configit's REST APIs. And this allows us to consume the data in a configurator, for example, in a CPQ system. It could be Salesforce or a custom app that you have created using our SDK. And this way, allowing users or customers themselves to configure the products without running into errors, because we have analyzed the models up front. So to summarize, we've covered a lot of ground in this short tech talk here, but we have seen how even simple products can have quite complex configuration. And as we probably all know, errors in configuration models can lead to some problems that you actually end up with situations where orders can't be manufactured. Configuration errors can be very costly and will damage your customer relationship. And traditional configuration tools offer very limited support, if any, for validating configuration models in this way. And we've seen how Configit's virtual tabulation technology allows you to prove correctness of your models from PLM and ERP. And I've shown how you can use interactive solution spaces to explore your product models and get new insight into the dependencies and the connection between the variables. So this is how we work with formal verification of configuration models at Configit. How do you work with product configuration models and rules in your company? Do you trust your models today? How do you align models from different sources? What happens if your data is not aligned? Please reach out if you are curious about how we can help you with your challenges in this area. And thanks for attending. And I believe we have time for some questions, Jan. So we're back to you.
Thank you very much, Jesper, for walking us through this exciting insights and showing us how can Configit Ace and virtual tabulation can actually make that difference. And there is time for a Q&A session. So I'd now like to open the floor for questions, and I could already see that a couple of them were already dropping into the chat. So let's have a look. So here's a good question. So how does virtual tabulation handle extremely large and complex models in practice? Are there the limits in terms of variables, I assume, rules and performance?
That's a very good question. I mean, in the practical limit is rarely, you could say, the size of the model or the number of rules. It's more about the complexity of the rules. So I would say, I mean, virtual tabulation is based on BDDs that handles very complex models in a very efficient way. During compilation, we, so to speak, compress the solution space down to something we can manage. And in practice, we have validated models with thousands of variables and rules, trillions of configurations. And usually that can be done quite efficiently. So we're talking usually minutes or seconds on a standard piece of equipment. So it's about the complexity of the rules and how complex an engineer or a person can actually formulate rules, which is typically the limit.
Thanks for providing this insightful addition. So here's another question for you. How easily can this be integrated into other systems like PLM and ERP? Do we then need to remodel, or how does it work in practice?
I mean, no, the principle is that we can extract the data from existing systems using our extractors. So we have a software that can extract data from both the PDC and SAP. And this allows us to reuse the rules from these source systems. And because we have a standard modeling language, we can convert those rules into that language. We can process the content, give it to our compiler, and create data packages, VT packages, as we call them, that we can work with in the Configit Ace product. So yeah, you can certainly keep your models in the existing systems, extract them with our software, and expose them in our technology. And then, of course, once you have the data extracted and aligned, checked, verified in our solution, you can expose them, configure them in the systems that you want to use, CPQ, for example, or build your own application on top of it. So the transition to use this solution here should be quite smooth.
That sounds indeed like a very smooth solution in terms of this question about remodeling. So there's another interesting question here about block values that you mentioned when showing the actual solution, Jesper. You mentioned block values and misalignments. Are there other common types of configuration errors that the configured approach can help uncover?
Yeah, that's actually a good question. I mean, we often see when we engage with a customer and get access to their configuration rules that sometimes we even discover completely contradictory rules. So that means that a set of rules that will make the entire product, let's say a set of variants, unavailable. So you end up with a solution space that just collapses into false. So we've seen that sometimes. So it's not just a single value that is blocked, but simply a set of rules that together have the combined effect that no configuration is available. And it's very, very simple with our technology to find let's say, sets of rules like that if they occur in a product model. That will come up right away when you compile the product model. A second thing we sometimes see is that, I mean, it's a bit softer. I mean, it's rules that don't really work as you expected them to work. You know, we often see people have an if-then rule or an if-then-else rule, and they don't get the condition right in that rule, so the rule doesn't sort of point in the right direction. So they get an error in the solution space, right? They don't get the rule doesn't restrict the allowed values as the modeler intended. So that's also something we often see. So yeah, so you can say during compilation, we can detect a lot of inconsistencies in your models, block values, contradictory rules. And once we have the data in, we can perform the type of validation and analysis that I just showed to pinpoint what rules are problematic in your model.
Thanks for providing that additional insight. So here's another question in the PTC context. So what is the prerequisite from PTC in terms of configuration, implementation, and Windchill, like O&V, effectivity, and BOM views?
Yeah, so now it gets a bit more sort of into the details. So we work with the options and variants module in PTC Windchill, and we can extract the options and variants that you have defined and the different types of rules that are associated with the model that you set up in PTC Windchill. Currently, we do not extract the bill of material and include that as a standard product or in the standard extractor. This is on our roadmap, and that will allow us also to do BOM validation. We actually have the technology in our product today, so we can perform that type of analysis. So what we need is simply to get the data out of PTC and be able to process it in our tool. And this actually allows us, it's a very interesting topic because it allows us to verify that the selection conditions that you have defined on your bill of material items, that they are actually aligned with your logical model, so that you don't over-engineer or don't under-engineer the bill of material, so that you don't have, for example, items on your bill of material that you can never select because the selection condition level will be fulfilled, or maybe you have two items on your bill of material that will be selected at the same time, which you perhaps didn't expect.
Thank you so much for providing these extra insights. I hope that the question was answered by giving this information, Jesper. So we're reaching the end of the Tech Talk, and that's all we actually have time for today. I want to take the opportunity to thank Jesper for his excellent presentation and giving the insights in the Q&A, and especially to all of you for joining us today. But there's still the option to ask a question if you still have one. You can just post them in the chat. We will definitely collect all those together and answer the questions in a follow-up after this Tech Talk. So I wish you a lovely rest of your day.
Thank you. Thanks for attending.
Bye.
Bye.